Okay, this is going to be a walkthrough for the potential difference in circuits worksheet. First off then, question 1. If we start at the cell and we follow the wires around, we see that at some point they split. So this section here we could call the junction. So those electrons will flow either that way or this way down this wire. Therefore we know it is a parallel circuit because there is a junction of those wires. So the rule for potential difference in parallel is that it stays the same across each branch. So if we started off over here in V1 with 5 volts, that means this branch must have 5 volts and this branch must get 5 volts. So our answers here are 5 volts and 5 volts. On to question 2. Again, we start at the power supply, in this case the battery, follow the wire around, doesn't matter which way, and over here we see we either go left or we go down. That means it must be a parallel circuit because the wire splits into more than one wire. So, again, rules for potential difference in parallel is that the potential difference stays the same across each branch. In this case, V1 is 6 volts, so there must be 6 volts across this branch and 6 volts across this branch. So first off, there's only one component here, so it must get all of that potential difference. So V2 is 6 volts. Then these two components, these two bulbs, there are 6 volts across this branch. But on this branch, these two bulbs are in series. We could say they're in series with each other on that branch. Okay, so the potential difference will be shared between this bulb and this bulb because they are on the same branch. So V3 is therefore 3 volts and V4 is also 3 volts. Okay, and the reason for that is because the potential difference in series splits. So because we get 6 volts in total on this branch, but these are in series with each other, so it splits, we're going to assume they're identical bulbs and that it's an even split. So 3 volts each. Okay, question 3. Again, this is a parallel circuit because at some point over here there is a junction, the wire splits. Right, we are told that V3, I'm just going to write it here, is 0.5 volts, and we're told that V4 is 1.5 volts. So this is one branch, this is the other branch. If this branch gets 1.5 volts over here, that's this branch, then that means each branch must also have 1.5 volts. So V1 is 1.5 volts, okay, because the potential difference in parallel is the same across each branch. That's the rule. Then V3 over here is 0.5 volts, and across this branch there must be a total of 1.5 volts, the same as this branch and this branch. So if we've got 1.5 volts over here minus this 0.5 volts, leaves us with 1 volt for V2. Okay, and question 4. When we consider series or parallel, we ignore any type of meter. So these voltmeters we can ignore, and V1 we can ignore as well. So if we ignore them, we're left with just one box. There are no junctions, so it is a series circuit. The rule for potential difference in series is that it splits. Okay, so it splits, but not necessarily evenly. We have a look at the cell, we are provided with 4 volts. So those 4 volts get split between these 4 components, not necessarily evenly. It says, assume the bulbs are identical. Therefore, the split must be equal between V5 and V2. So if we look here, V5, we know is 0.5 volts. That means V2 must also be 0.5 volts. Okay, which leaves us with just one. And we know that the sum of these 4 must equal 4 volts, okay, which we're provided with. So I'm just going to add these up. Got 1.5 plus 0.5 is 2. So that means V4 must get the other 2 volts because then these add up to equal V1. 2, 3, 4, yeah, that's correct. Okay, question 5 then. Okay, again, ignore any type of meter, and you'll see that this is just a funny shaped series circuit. Okay, so then the potential difference in series splits, not necessarily evenly. We have a look, V2, V3 and V4 add up to give me, look at this is millivolts. Okay, 200 millivolts equals 200 times 10 to the power of minus 3 volts. So that's 0.2 volts. So 5 plus 2 plus 0.2 volts gives me 7.2 volts. And those all add up. Okay, question 6. Over here we can see there is a junction, so this must be a parallel circuit. So across each branch there must be 250 millivolts. This one's quite tricky, so we're going to approximate it to, first off, to this circuit. So that the first bit is the same, and then this bit has the parallel section. Okay, but we're going to say something over there that we're not too sure what that is yet. We can call that a black box because we're not too sure. Okay, let's have a look. Across here we have 83.3 millivolts. Yep, we are provided with 250 millivolts. This one in blue that I've drawn is a series circuit. So we can say, so we know that this plus this plus this must equal 250 millivolts. We are assuming that the bulbs are identical. Okay, so if these bulbs are identical, they must have the same potential difference across them, which means this unknown thing, if we do 250 minus these two numbers, we are left with 83.3 millivolts here as well. So this unknown thing must have a potential difference of 83.3 millivolts across it. Now we have a look over here, and that unknown thing is actually a parallel section. So I could maybe just about add it in. Okay, it's a parallel section. I'll just put that to the camera. Okay, this is actually a parallel section. We know that the potential difference in parallel is the same across each branch. So if there is a total of 83.3 millivolts across each section, it means there must be 83.3 millivolts on this branch and 83.3 millivolts on that branch. So both V3 and V5, this one's actually given to us already. We don't need that information though. V3 must therefore be 83.3 millivolts, and V2, as we saw over here, is also 83.3 millivolts. Okay, this one was really quite tricky, so if you've understood that, then you're doing really well. Finally, the bonus question: if the current passing through bulb 3 in circuit 1 is 10 amps, what's the resistance? So we have a look at circuit 1. Bulb 3 is likely this one, and we're saying that the current is 100 amps. What is the resistance? Across V3 we need this bit of information. There are 5 volts across that bulb. Okay, and this hint, use V equals IR. We'll be learning about that later. That is Ohm's law. Use that equation, V equals I times R, potential difference, current times resistance. Okay, we then can substitute in the values we know. We know it's 5 volts. The current we're told is 100 times R, that resistance. So we can rearrange the equation to get 5 divided by 100, which is 0.05, and the unit for resistance is ohms. Sorry, it was not in the camera. Okay, the unit for resistance is ohms. So there you have it. The answers to potential difference in circuits.